Hey everyone, I'm going to be walking you through how to execute the Driverless AI MOJO scoring pipeline in Apache NiFi. And we're going to also build out a NiFi Data Flow. So to begin, we'll be referencing this GitHub repository page, and we'll also be referencing the text editor here, some properties that'll help with building out the data flow. So we're going to start in AWS. We're going to click on the EC2 instance. Alright, and we want to launch one. We'll be launching Ubuntu 18.04. We're going to go with T2 2x large. Let's add 256 gigs. It's a good amount of storage. Alright, and then configuring, we're just going to configure 8080. That's for NiFi, so we can access it at that port. The source we kept as default, so that's good. This is just reviewing before we launch the instance, and looks good. And then we're going to select our key pair. We're going to choose EC2 model deployment, acknowledge, launch. Now we're going to grab our public DNS, so it's been copied. We're going to update our environment variable that holds that in our bash profile. So here we see export H2O scoring instance. This is the previous public DNS. Alright, let's save it. Close and open the shell. Alright, now we should be able to SSH, so I'll just do a grep history grep SSH. I'm going to use this command here. And the PEM, H2O scoring PEM was an environment variable too in the bash profile. With that, now that we're SSH'd into the EC2 instance, let's install Anaconda for Linux. Run wget, that link. We'll also want to go to the NiFi downloads page. We'll download 1.11.4 in tar. Once this download finishes, we're going to install Anaconda. And I'm going to open another folder. This folder, it has some of my install. It has some of the install packages, the commands to install packages for our environment. So while we wait for this to finish, NiFi finished downloading. Let's install Anaconda. Enter. It's going to go through the terms and agreement. Type yes. Default location to install. So yes, exit, SSH back in. Now we see Anaconda has been installed. What we're going to do next is we're going to create our Anaconda environment, call it model deployment. Then we're going to install OpenJDK 8. That is required. It's recommended for executing the driverless AI mojo scoring pipeline. Then we'll install Maven. We'll need to compile our NiFi processor. Alright, we're going to git clone this repository. So this particular one at branch NiFi, the MOJO py NiFi CDP, git clone p-b MOJO py NiFi CDP. Alright, and then what we'll do is we're going to export our driverless AI license key. So with us being on Ubuntu, we go to Profile. At the end of Profile, add export driverless AI license key, and then you copy and paste in the driverless AI license key. Driverless AI license key has been copied in. We'll exit. We'll SSH back in for those changes to take effect. Alright, we're going to activate our environment again, on the deployment. Okay, next what we're going to do is we're going to compile our NiFi processor. So in the data deployment examples, go to NiFi, MOJO NiFi, model deployment, follow this path. We'll run Maven, install. If you wanted to edit the code, you would just have to run this next command, right? And this is downloading the jar package dependencies for the Eclipse project, and then open Eclipse on your local machine. So we have cloned the data deployment examples repository into this Ubuntu server. Alternatively though, if you wanted to work on the code, you could clone this repository onto your local machine, compile the project, download the jar package dependencies, start up Eclipse, import the project into Eclipse, and then edit the code as you feel, as you want to. In our case, so we're just going to wait for this to finish compiling, and then we're going to copy over this NiFi nar, they call it. It's the NiFi library for this custom processor, to the NiFi library in the NiFi 1.11.4 folder. So what we see here is our processor, the project finished compiling. Now what we're going to do is we're going to copy this nar over to our NiFi lib. So finish looking, going through the path, NiFi nar. target this nav here. We'll get the path, go back to the beginning, the root, open this tar.gz file. We're going to copy this path that we need, this one here. Now we're in the lib directory. We're going to copy this nav file over. We can see here it's the newest file added. Now we're going to start NiFi. We can monitor where NiFi is at in its start process by going into the logs. So I'll do a tail-f, go to the logs folder, NiFi app log. So the Jetty server is running at that particular address. So we'll get our public DNS at 8080. This is so that we can access NiFi UI. So here we have this visual canvas. NiFi is a drag and drop approach to building out data flows, so we don't need to worry about coding. We can use a git file to bring in our data from the local file system, and then we can use an update attribute processor. This will be actually used for, we're going to create what is called flow file attributes. One particular flow file attribute that will be telling NiFi what our schema will be called. So as we add this other processor, which is ExecuteDaiMojoScoringPipeline, NiFi makes it really easy. You see, we built this custom processor, and when we search for it in this add processor window, it's just right there. All we have to do then is add it. Here's the processor. We just have to configure the properties for it, and then we can have NiFi execute the driverless AI motor scoring pipeline on the data that's coming into the processor and make predictions on that data and then pass it on to the next processor. So we're going to use another update attribute processor, update attribute, and this will just be to make a unique file name for the files with predictions that we'll be saving to the local file system. So we'll use profile. And what we're going to do, we are going to specify where the data is located. This is the input data. So I'm just going to go to the path itself. So it will be MOJO NiFi model deployment, common, going into hydraulic because we're dealing with hydraulic system data, going into test data, and we're interested in test real-time data. So here's our test data. We're going to get the path here. So we already got the first few directories. We're just going to add the remaining. There it is. Alright, and then we're going to specify keep source file to true. Alright, and this is going to simulate NiFi pulling in hydraulic condition monitoring data that then goes through this data flow of processors, and we run the predictions on the data using the ExecuteDaiMojoScoringPipeline processor. So we'll do the connection here. Also, one more thing I need to do is I need to update the scheduling in the file processor. There it is. Next, we need to specify a new property in the update attribute processor. It's going to be called schema.name and test schema. So test schema is the schema for our incoming data coming into this particular processor here, ExecuteDaiMojoScoringPipeline. To the next connection. Alright, now I'm going to show you how easy it is to configure this processor, whereas before you would have to write the code out in order to use the Driverless MOJO-Scoring-Pipeline. So we just have to specify a record reader. So this is something that comes with NiFi. It's a controller service. And we know well, to give you guys a little bit of background, the data that we're going to be pulling from the file system is CSV data, and their individual rows of data within each file. So we'll tell NiFi we want to use CSV reader. That CSV is the data source we're going to be pulling in. There's other options. You could be working with other kinds of data sources, so these are the particular controller services you could use, but we'll stick with CSV. And then for a record writer, these are the different data formats you can write your predictions onto. But to keep it simple, we're going to use CSV record set writer. And then we need to specify our MOJO 2 runtime jar directory, so the path to the MOJO 2 runtime. So that's where this path comes in. So we have DAI deployment examples, right? This is the path we're going to use. And since we're on Ubuntu, we just need to specify home, Ubuntu, and then the remaining path. See, I'm going directly to the jar file itself. Okay, and then for the next one, it's the pipeline mojo file path. So we just have to specify the path to that pipeline.mojo file. So DAI deployment examples all the way to pipeline.mojo. And again, we're on Ubuntu, so the home path is home Ubuntu, followed by the remaining directories in order to get to the file. So this is what you need to do when you're configuring the properties for this new processor. The other thing we need to do is we need to configure the controller service properties, so CSV reader and CSV record set writer. So we're going to go to that, click yes to save the changes. Alright, and these are the two controller services. We'll start with CSV reader. And we're going to tell NiFi that the schema access strategy is going to be to use the schema name property. So now NiFi will know I'm going to use the schema name property in the schema registry. Using the schema name property will help with searching for schema names in this Avro schema registry. And you can see there's other ones, but Avro schema registry it comes right out of the box with NiFi, and it's very easy to use. We'll click yes to save Avro schema registry. So earlier we saw a cache symbol, squiggly braces, schema.name, and that's a NiFi expression. What it simplifies to is test schema. Remember, we added a new property to the update attribute processor where we specified schema.name, and then the value for that is test schema. Alright, and now we just have to specify what our schema is for the incoming data to this processor. And all I need to do is just get this schema here. So I have it ahead of time, but what I'd recommend is whatever your test data is that you're going to be passing into the processor to do predictions, just make sure you look at the column names and then look at the values. Like, what is the data type? What is the data type of the values? Okay, and what we see, we have about 16 columns per record, The name, I chose it to be hydraulic test data because the kind of data we're dealing with comes from hydraulic system. And then namespace, org.apache NiFi. And you can choose these names. They don't have to be, they can pretty much be anything. Type, though, you'll want to make sure you specify that that's a record, because we're dealing with records. Click OK, click Apply. Now, we need to just verify the configurations for CSV record set writer are what we want. So we're telling NiFi with this first property schema write strategy, I'll show you. It is do not write schema. Do not add any schema related information to the flow file. So I just showed you the schema for the incoming data to this processor, but there's also schema for the data that's leaving the processor. And there's different ways you can write the schema, like different places you can write it. So you could you could specify it in the AWS schema registry with another schema name and have its value. You could also write the schema directly to the flow file that leaves this processor. But what I recommend is leaving the configuration as default so we don't write into the flow file content. You could use schema name though if you wanted to, and then you just specify it in the AWS schema registry. Alternatively though, instead of doing that, we could just tell NiFi, I want your schema access strategy to inherit record schema. And a cool feature that NiFi has is once it uses this processor to make the predictions and store them into a flow file, so flow files are what are moving throughout the flow. Each record NiFi writes has a schema. So there's a schema for the output data that leaves this processor. And when we look in the code, what you'll see is NiFi is, well, we're writing the code so we're able to identify what the field names are and the field types are for the prediction data. So yeah, we'll leave this as default. Okay, we're going to enable the AWS schema registry. And then we're going to enable CSV reader and CSV record set writer. We have a few other properties, so we're just going to auto terminate on failure, auto terminate on original. Final one, we're just going to make that connection, and on relationship success, we're going to route to the next processor. So this will be sending the predictions to the next processor. And what we want to do with this update attribute processor is let's create unique file names. So file name followed by predict hydraulic cool condition. We're going to use the NiFi expression here for UUID, unique identifier, followed by .csv for this CSV file. Click add. Now we're going to specify where we're going to store the data. So it's going to get stored in hydraulic. There's going to be another directory called predict and then predict real time. So we'll just get this path leading up to it. And then predict data, predict real time data. Conflict resolution strategy. So what happens if NiFi writes a duplicate file to local file system? Let's replace any existing files with that name. Apply, 2 more, settings, failure, and success. We'll auto terminate those. So now we have our flow. Let's test it. Awesome. So what we see here is we just built a flow with this new processor that's able to execute predictions using Driverless AI's MOJO scoring pipeline. And in our case, our use case was working with hydraulic cooling condition data. I'll show you what the predictions look like. So one way is to get the path to where the predictions are being written. And they are being written here. Here are the files. Whoops. Okay, so what we see here is there's 3 different classifications, right? So there's you're classifying for the probability that cooling condition is 3, 400, 420. And what that means, 3 means is the hydraulic cooler is close to operating at total failure. 100 means the hydraulic cooler is operating at full efficiency, and 20 is it's operating at reduced efficiency. Now, to expand on this use case, what we could do is we could build further along this NiFi flow and create an alert notification mechanism where if the 3 or the 20 reaches a certain threshold, right, for the probability that the conditions happen to be 3 or 20, we'll notify the person who's in charge of managing the maintenance on the hydraulic system, so then they can take immediate action to do predictive maintenance. Now, a bit of the work that went into it in the back side. So the code. Before, what you'd need to do is you would need to load your MOJO scoring pipeline. So we're using the MOJO runtime, the MOJO 2 runtime jar, or you can think of it as the MOJO API. And in the Java code here for this processor, this is where we load the MOJO scoring pipeline. Next, what we're going to do, we need to run the predictions on the records that are coming into this processor. So where we do that is we have a predict method. I wrote a predict method. And here's the first record. We're using this model to perform classification on the first record. And then for the remaining records, we're looping through them and we're performing classification. Where the method is, this is where all of our MOJO API code is to allow NiFi to execute the MOJO scoring pipeline. We're taking each record map and we're using the MOJO frame builder, the MOJO row builder. We're looping through the record map. So just think of one individual record or a row of data. We're looping through all of the column entries that are in there, and we're using row builder to set the key value pairs to add a row using frame builder. And then with frame builder, we're constructing a MOJO frame, an input frame out of that row. And then this is where we use the MOJO scoring pipeline to the model itself to perform the classification on that input frame. And as you can see here, these are our classification results. Now, NiFi doesn't work with MOJO frames, so we need to convert this to something it does work with. So we're going to convert this to a record. And in order to convert it to a record, NiFi can take a hash map. So we're going to extract out the contents we need from this output, this MOJO output frame. So we're going to loop through this output frame, and we're going to get the key, this is the field name, and the column data. Now with the column data, what we're going to do, so that's the column entry, right? We're going to check what the data type is for that column entry in that row, right? And we're going to do, is it a boolean, is it an int, is it a long? In our case, it's a double, right, as we can see from the output, of course. So we're going to convert that column data to being a double type, and then we're going to use record maps put method to store the key value pair there. And then once we're done looping through the MOJO frame, the output frame, we're going to then use NiFi's data type utils to record method to convert that predicted record map to a predicted record. Provide that back to NiFi, and then allow NiFi to finish executing the predictions on the data. So that was just to show you a bit of what went into building this processor, but you won't ever have to deal with the code unless you want to make an enhancement to the processor or add on to the processor. So this is what it takes to embed the H2O Driverless AI Mojo Scoring Pipeline into Apache NiFi. Also, this software comes in Cloudera Data Flow, and there's a tool called Cloudera Flow Management. If you were to download Apache NiFi directly from Cloudera, but we got it from the open source. So I hope you had found this to be insightful and have fun deploying machine learning models.